welcome to Friday's edition of Cracking the Cryptic, where today we're going to be taking a look at this rather numberless puzzle on screen called Pepper and Salt by Easily Amused. And I'm told that this one is sort of approachable, so it might be a bit like yesterday's by Sed Holleyson, which was a wonderful puzzle. And lots of you have commented how much you enjoyed trying to solve that one, so hopefully this will be another puzzle that everyone can have a go at. Now, I will tell you this is the second puzzle I've done today, because earlier on I recorded a solve of this puzzle. I've had to do stuff today to take my mind off what is going on outside, where we seem to have some sort of hurricane. And those of you who follow the channel may know that I record these videos in the attic at home, basically. So I'm very high up, surrounded by large oak trees, and they are whipping around. It is absolutely terrifying. So anyway, I did this one earlier. It is an amazing puzzle. It's called Balance Equals Entropy by Jeremy Dover and Raum Planer. But the rules are quite complicated. It involves this concept of entropy, where you have to basically divide the grid into low, medium and high digits. And also you can see there are all these scales going on. So, you know, like this digit weighs more than these two digits. And you've got to make sure that the torques applying on each fulcrum are equal. So it's really fascinating. It took me about an hour, but I was very distracted by the wind. What we're going to do, I think because we're a bit nervous that it won't be for everybody, this puzzle, we'll put it on Patreon, so that should be there by the time you watch this video. So if you did want to look at how to solve balance equals entropy, and I definitely recommend having a go at the puzzle even if you don't watch the video, then do check that out. Now back to this one. Do I have anything else to tell you? I don't think so. I'm very nervous as well because there are reports of power cuts all around the area, so I think I should just crack on and we'll get this done, and hopefully there won't be a power cut and we will have a good video for everybody to watch by the end of the day. So what are the rules? The rules are as follows. Normal Sudoku rules apply. Cells separated by a knight's move in chess cannot contain the same digit. Let's make sure we understand what that means. So let's imagine the central cell of the grid was a 1. If this was a chess knight, it could jump to all of these cells. And therefore none of these cells I've just highlighted could be the digit 1 in this puzzle, because if they were, they'd be a knight's move apart. And in this puzzle, that's not allowed, so don't do that. Now, cells separated by a black dot must contain digits in a ratio of 1 to 2. It says i.e. 1 is double the other. So what that means is, let's look at this black dot here. One of these digits is double the other one. So if this was a 4, that could be a 2 or an 8. If this was a 3, this would have to be a 6, etc. So that's how black dots work. And cells separated by a white dot must contain consecutive digits. So if this cell here was a 2, this square would have to be a 1 or a 3 to make sure that this domino contained consecutive digits. Not all possible dots are given. That's just there as a negative constraint. So that's telling us, I don't know if you can hear the wind, by the way, it is battering the house. Anyway, that's just telling us it's perfectly possible for, in this domino, for one of the digits to be double the other. There doesn't need to be a black dot in any domino that has this feature. It's just that we know for sure that this domino does have that feature. So do have a go. The way to play is to click the link under the video. And now I get to play Let's Get Cracking. I even understand the title today. Obviously these are black and white specks of condiments that we've sprinkled on our Sudoku. Now, there are some things actually that I know about, especially when we get black dots in a triple like this. There are two things I can tell you about this. The first is that there must always be the digits 2 and 4 in this string. And you can see that because if you think about the nature of a black dot on its own, let's look at this black dot, and we think about what we could include in this black dot. Well, we can include a 1 and a 2, they would go together. A 2 and a 4 would go together. A 3 and a 6 would go together. And a 4 and an 8 could go together. That's the 4 possible sort of configurations we could have along a black dot. But when you string them up like this, you can no longer involve the 3 and the 6. Because if you try and do that, whoops, if this was 3 and this was 6, this square would now either have to be 12 or 3 again. And you can see that's not going to work. So what we can do is things like 1, 2, 4 or 2, 4, 8. either upwards or downwards, but you can see that there's always a 2 and a 4 in that little trilogy. Now the other thing, if you were concentrating, you might have spotted, is that the middle digit, whenever you're doing this, is always a 2 or a 4. So that means that we can put 2 and 4 here, and we can repeat that trick, I think, in all of these little triples around the grid. Yeah, there's loads of them. There is loads of them. That's another one. Okay. Now this is already very interesting to me, at least. Because now I can... Let's do the 2-4 highlighting as well. There's always got to be 2s and 4s in these triples. 2s and 4s, 2s and 4s, 2s and 4s. But I don't want to get too hung up on that, because I can see something interesting here. And that is that these two cells cannot be the same digit, because these are a knight's move apart. And that suggests to me that we might need to think about colouring here. Yeah, we do. This is really beautiful, actually. So let's start by thinking about colouring. Why do I want to colour? Well, it's to differentiate the fact that whatever this is, if this is a 4, this couldn't be a 4, so it would have to be a 2. So I want to keep track of the fact that these are different, and I definitely want to keep track of it in light of this cell. Now this cell cannot be 2 or 4, actually, because if it was, let's just make this a 2 to show you what I mean. If this was a 2, you could no longer put 2 in any of those 3 cells because of the knight's move constraint. 2 would be ruled out from those 2 cells, they're a knight's move away, and 2 couldn't go here by plain old Sudoku. So this digit is not 2 or 4, and therefore it is 1 or 8. And this digit is 2 or 4, and that's exciting, not only because it's not green, but that means it must be purple. Which means purple is in one of these 2 cells. Oh, no, look. This purple sees that cell, so that's now green. That means this one's purple, and now we're getting full colouring going. Or are we? Oh. I was hoping that was going to go further than that, I will be honest, but it doesn't seem to have done. So how can we do better than this? Well, yes, okay, we can colour the 2-4 that's not in this cell on this line, because this green sees this cell, and there must be a green and a purple on every string. So this is green. Therefore this square is 1 or 8. Now that's interesting, isn't it? Because these cells are now seeing each other. So that feels like it might be... We might have to colour the 1s and 8s. Wow. Where does the green go in this string? It must be here. It's never felt dangerous to solve a Sudoku before, but it does actually feel a bit dangerous for me to be in this room at the moment. Now, let us carry on quickly. Can you hear that? I'm tempted to take a video of it. The trees are going bananas. Please don't let anything fall on me. That square's got to be a purple. This square can't be, because it couldn't be green. This square can't be green, so that must be green. And we've got another little arrangement of 2s and 4s here, which means this square must be 1 or 8 by the power of magic. That square can't be 2 or 4 now, so this is a 2-4 pair. We can colour these in as well, using these 2, look. So those 2 are done. This must be 1 or 8. That dot now is interesting to me, because if this can't have 2 or 4 on it, and it can't have 1, 2, 4 or 8 on it, so it must be a 3-6 pair, which is a little surprise for us. Can we colour these ones in? Or can we conclude something about this black dot? Well, although this square can't be 2 or 4, I think this one might be able to be purple. It can't be green. And if it's purple, this could be a 1 or an 8. And that seems to be acceptable. So we're going to have to do better. Now, I wonder if it's something to do with the fact that the 1s and 8s... Yeah, this is interesting. The purple 2-4 will always have a 1 or an 8 attaching to it that's different to the digit that would attach to the green 2-4. So this might be something we need to think about now. And that's because, let's imagine we worked out that purple was 2. If we know purple is 2, we know green is 4. So we know that this digit, the digit that's attaching to purple along these black dots, is a 1. And that's always going to be the case. If on the other hand we made purple 4, then we know this would be 8 because this would be 2 because this is the other of 2 and 4, and now this would be 8. So purple would be attaching to 8 if this is 4, and therefore green would have to attach to 1. So we're going to... These are different, but we knew that anyway. Once we knew these were different. So I'm just wondering whether what we should do is... Yes. Okay, yeah, let's do this. I'm going to colour in every 1-8 that attaches to purple, because I know that those 3 digits are the same. That's purple as well, isn't it? So that's the same. So this square here will be the different digit, whatever that is. But we know that because the 2-4 is in the middle of this is beautiful. This is beautiful. This is it. This is it. We've done it. Well, we may not have done the puzzle, but we now know, because this 2-4 must have a 1 or an 8 attaching to it, either this side or this side, and it's not here anymore, so it must be there. And that means this cell is now, you've guessed it, purple. There's always got to be a purple on each of these black dot lines. Now, does that actually do stuff for us? It means that... Oh! Right, it does do something for us, or at least a little bit of a something for us. Yes, look at this string of digits now. And by Sudoku, you can see one of these digits is purple, which is one of those 2 cells, and one of them is green. Green can't go there because of Knight's move, so green's in one of these 2 cells. But what we can't do here, is put this cell as green, because there's a 2-4 in this row already. So actually, we can place green in the top of the grid, we can place purple here, and we know that purple, because it can't be next to green, it must be therefore next to blue. That's the only other thing it can be next to. And this square is on a triple and it can't be... this is so clever. It can't be 2. So now we have disambiguated, as the wind howls outside, we have disambiguated our purple and green, because the option for green is now 4 or 2. Now if it's 2, how are we going to make this line work? These all have to be consecutive. We can't do that because 0 is not a valid Sudoku digit, so we must go up from 2, but now purple needs to be in 2 places in the box, and that won't work. So this is disambiguating our greens. Our greens must now be 4 wherever they appear. Our purples must now be 2s wherever they appear. Now we can see orange is 8, so blue is 1, and is the puzzle now going to yield to us? That's the question. I don't know is the answer, but it might do. 1 by Sudoku can just be placed in box number 4 there. So 1 by Sudoku must be placeable in box 7 as well, because there are 4 1s looking at that box. So we've now placed lots of 1s. We've placed 7 1s. There's a 1 in one of these 2 squares. And that being the case, we know that this is not 2, 4, 8, don't we? Because there's a 1 on this line. So we know the middle digit now must be the purple digit. So that's purple. This is green. and there must be an 8 in one of those two cells, is the upshot of that. Now, can we work out which is which? Yes, we can. Okay, so now we know that there must be a purple in this string. It must be here. So that's not 8. So this is 8. This is 2 or 4. Let's tidy up some of these pencil marks, which we don't need anymore. Whoa. Absolutely. Oh, where does 8 go in box 6? By Sudoku and Knight's Move Sudoku, it goes there. So that's an 8. Oh, that didn't sound good. That could be something. That really didn't sound good. I might have to go and check what that was. Something just definitely broke. Okay, orange's turn. Orange turns 8. I better go and check. I'm sorry. Okay, I can tell you that is an oak tree that has split. Its trunk has split about 10 foot off the ground, and the whole of the top of the tree has gone. But luckily it's gone away from the house. So I might take a picture of that later, but not at the moment. I'm not going outside at the moment. Anyway, where were we? 4, that can't go downwards. So, because if it goes downwards, it'll hit 2. So that must go upwards. 5, 6, 6 and 3 go in. Now, do we have colours for any of this? No. That's a bit remiss of us. Oh, but I can colour green on this line. That's got to be green, hasn't it? We know what green is. Green is 4. That's 2. That's 1. That's 4. So we're getting some stuff done. That needs to be blued in. Blue must be placeable here by Sudoku. How many 1s have we got? All of them. How many 2s have we got? All of them. How many 4s have we got? All of them. Okay, so we just need to get more 8s, which we can do. That must be 8, and 8 deserves to be orange, and 8 must be placed here by orangeness. 8 must be placed in one of 2 cells in box number 8 there. Yes, so where does, oh, this is lovely, right, where does 8 go in box 5? It's by Sudoku, and the fact that we can rule out 8 from here by this pencil mark, it has to go here, but in placing it there, it sees this one by Knight's Move, so it actually gets placed down here as well. And that means we can place it there, and we've probably done all the 8s. We have. Okay, good. So we've just got to do 5s, 6s. We've done. Oh, so this is a 7-9 pair at the top of the grid. Look, to complete row 1. Every white dot, it by nature must have an odd and an even digit on it. And you can see if we look down here, 3 even digits looking at this white dot, so it must have the other even digit from 1 to 9 on it. So this has got a 6 on it, and the consecutive digits with 6 are 5 and 7. So this is 5, 6 or 7. But actually, we don't know much about that, do we? In the sense that we don't know much at all about 5s and 7s. In fact, virtually nothing. Oh, we know these squares are 5, 7 and 9, so perhaps this column is going to help us. 3s and 6s get placed into these cells. We don't know that much about those digits though either. 3s, 7s and 9s here. Oh look, I can do better with 6s because of Knight's Move logic. This can't be a 6, so I can place a 6 there. So maybe our next colour that deserves its own special branding is the 6, which can't be in those cells now. Can't be here. Must be in one of these. So it's in one of those, one of those, one of these, one of these, I suppose. One of those. Oh yeah, okay, look at box, that's where I should have looked. Box 8, the 6 is in one of these two, the 6 sees that cell, so the 6 has to go there because of the Knight's Move again. Doesn't seem to, it doesn't actually seem to do enough work though? No, I'm not sure that it does. How on earth are we going to finish this then? Is it the 5? Well, it would be interesting if the 5 was on this white dot. That would become a 5. There'd be a 5 down here. Okay, I'm not sure. Let me just not pause. I'm not going to pause the video, but I just want to have a think about this for a second or two and just see if I can work out what's going on. Oh, yes I can. Right, this digit. Where does that digit go in box 5? That's a reasonable question, isn't it? Because of the knight's move constraint, it gets removed from those 2 cells. By Sudoku, it gets removed from these 3 cells, and it already can't be 1, 2, 4, and 8, which it sees in its own box. So that square that's a 6, which means that's a 3. Okay, so now 3 is in one of those 3 positions. 6 is moved downwards on our white dot. That could be useful because it might actually reach far enough into box number. Yeah, look, this 6 sees that cell now by knight's move. So again, we get another 6 in the grid. We get the 6 ruled out of this square. We get a 6 placed in this square and a 6 placed in this square by Sudoku. And that's probably all of our 6s done. Yep. Okay. So now we've got 3s. Must be in one of these 2 cells. So we know we've got 1 3 and 1 5 in the grid. Oh no, 2 3s. Apologies, 3s. I overlooked you. And that is a 3 in the corner. And that's 3 in the corner. That's 3 in the spotlight, losing its religion. Although it may be losing its religion, but it's not helping me find anything. Okay. What about that cell? Where does that cell go in this box? And the answer is, because of the knight's move constraint, it can't go there, it can't go there, it has to go here. So those 2 digits are the same, and that... I don't think it does anything. I was about to say it gives us a 3 here, but actually these are grey, so grey is in one of those 2 positions. So we know these squares now are 3s, 7s or 9s, but we don't know which of these is grey. So that was a foolish place to look, Simon. Don't be foolish. Find some better logic, man. Okay, so probably, I think what we're going to have to do here is to spot a cell like this 6, where it's doing more work than you might give it credit for at first blush. Let me just take a stare at this for a second or two. Yeah, cells like this one. That cell, where does that cell go in the box beneath it? Well, it can't go here because of Sudoku, and it can't go in either of those 2s because of knight's move. So those 2 squares are the same. Does it stop there though? Actually, that might just... Oh no, it doesn't actually. That is interesting. Right, okay, I'm gonna have to borrow. Right, blue. I'm afraid, number 1, you've lost your bluage because I need to borrow it. This is blue now. This is blue for the reasons we just mentioned. Now, we can see that blue in box 9 is in one of those 2 cells. Don't know which one. But that means that blue is placeable in box 8. It has to go there because it can't go here because of the knight's move from this blue. And that's beautiful. That gets me a blue here. Now, does that just mean that's blue then? I think so. There's no other way there's no other place for blue to go in that box. Oh, but blue could be in either of those cells, so we don't know which of those is blue. And presumably we don't know which of those is blue. Although, can we use Sudoku to help us here? If we know one of these two cells is blue, yeah, that blue sees that one by Knight's move. Yes, so that's blue. Whoa, 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 whoa. That's not blue. I've got to finish this quickly. That's blue. Now I've still got to do something with these blues, and I don't see how to resolve them. I now know blue is 7 or 9, though. Oh, that does it, of course. Gosh, that's really clever, though. Blue is 7 or 9, so blue is not that digit. And that means that that digit loses its bluage, that gains its bluage, and that digit is also blue. And that's very important because now grey is definitely not blue. It's in the same row. So grey is 3. And blue is 7 or 9. So all of the blues become 7 or 9. That's not 3 anymore, therefore. So 3 is in this. So 3 is in one of those 3 cells. Oh dear, that still doesn't seem to tell us. Actually, these should be yellowed now, shouldn't they, to make themselves prettier. Where does 3 go in this box? Can't go a Knight's move away from itself. So that's the 3, which means that's the 3, that's the 3. This can't be 3 anymore because it's a Knight's move away. Oh, that's 3. Sudoku on this row. So that's 3. And all the 3s, 1, 2, 3, yep, all the 3s are done. Make them yellow. Oh, maybe what we've got to do is colour our 7s and 9s. I'm not sure if we need to, though. We've got to... Yeah, we can ask where 5 goes in this box. It's got to go here. And that places 5 over here, look. 5 can't go there by Knights. This is very nice indeed. It really is. That's a 5 by Knight, not by Knight's move, by Sudoku. That's a 5, so that's a 7. That's a 5. Blues become 9 because it sees a 7. So 7 must go in the other cells. These all become 7s. That becomes 5, that becomes 7, that becomes 7, that becomes 5, that becomes 7, and that becomes 7. And I think we just got a flurry of activity there to finish the puzzle. I'm just checking. I think it should only be 1s, 5s, and 7s that are uncoloured. And I don't like leaving things... Yeah, I think that's right. Yay! That's very nice, isn't it? Very nice puzzle indeed. Easily amused. I love that. I better get off for fear of the power cut, etc. Thank you so much for watching. I hope you enjoyed it. I really hope you had a go at the puzzle, which was magnificent and very, very beautiful. And very colourful as a result. And we'll be back later with another edition of Cracking the Cryptic.